This is the Digital Factory podcast. I'm John Brunner. The question of whether 3D printing is sustainable is the subject of a great deal of folk wisdom and speculation. But today I'm speaking with someone who's run the numbers and applied the models and has come to some nuanced and at times surprising conclusions about just how sustainable 3D printing really is, as well as some insights into how you can make your 3D printing work more sustainable by changing the ways you use your 3D printer and the types of designs that you produce on it. The Digital Factory podcast is brought to you by Formlabs, which makes powerful 3D printers that professionals can use from desktop through production. Visit formlabs.com for more information and join us at the Formlabs User Summit in Berlin on October 1st. For more information on the Formlabs User Summit, visit summit.formlabs.com. My guest today is Jeremy Faludi. He's an assistant professor of sustainable design at TU Delft. Jeremy, it's great to have you on the program.
Happy to be here.
Now, there's a great deal of hand-waving out there around the topic of 3D printing and sustainability. If you talk with people in this field, there's the question of, whether 3D printing is more sustainable or less sustainable than other forms of fabrication on the basis of waste that's produced or energy that's used, complexity of supply chains, whether or not it's important that materials are or are not recyclable, whether there's a greater impact from the fact that you can fabricate more efficient, better suited, geometries using 3D printing. So let's begin with a very general question. What would it mean for 3D printing to be sustainable? And how would you go about characterizing that?
Yeah, so I'm a big fan of measuring things, like actually quantifying, because there's a whole lot of, like you said, hand waving about what's greener or not greener. There's a lot of knee-jerk reactions that people have that when you actually run the numbers on things just aren't accurate. And so the way that I usually measure sustainability is called life cycle assessment. It's like doing a carbon footprint of things, except carbon footprint is only one variable, one category of environmental impact. And the life cycle assessments, or LCAs, that I do generally measure 18 different environmental impacts. So climate change is one of them, but there's also ozone depletion, acidification, eutrophication, water depletion, fossil fuel depletion, mineral depletion, land use, toxicity, ecotoxicity, blah, blah, a whole bunch of things. And then you can look at all of these different variables and really add up the numbers of, when I use 1 kilowatt hour of electricity from the US grid, what are the impacts of that? And how does that compare to digging 100 kilos of ore out of the ground to get 1 kilo of aluminum or something like that? And you can compare these things even though they're radically different. You can compare them to the transportation impacts of getting that kilo of aluminum from the factory to the customer's doorstep. And you can compare that to the impacts of throwing the product in a landfill at the end of its life. And it's a consistent meter stick to measure everything by. It doesn't measure social impacts, but it does, and it doesn't even measure all environmental impacts, but it's pretty much the best tool out there today.
So you start with this kind of model that incorporates all of these impacts and incorporates, I've read in your papers, not just, the chemical impacts of the materials that 3D printers use, but also the embodied energy and materials in the machines themselves, the amount of energy that they use when they're idling, when they're running. So you're starting with a model that tries to quantify the sorts of things that people get into in barroom conversations where they're like, well, yeah, but it uses non-recyclable material over here, but it uses less energy to operate over here. So how do these models incorporate factors as disparate as like ozone depletion versus climate change?
Yeah, basically, if you're asking the way that they come up with the data, what it is basically a set of giant databases where people have gone to actual factories and measured the amount of CO2 emissions, methane emissions, nitrous oxide emissions, coal dust or whatever, particulate matter going into the atmosphere, et cetera, et cetera. And so they have numbers in these databases for, if you're using 1 kilo of aluminum, let's say, in the printer, it will cause this many impacts from the entire process of digging bauxite out of the ground and refining it into aluminum and shipping it to, your location, et cetera, et cetera. And you can compare that to, like I said, the electricity use of different locations. So, you can choose solar power or coal power or nuclear power, and you can just say, I'm using average US electricity, and it can know the U.S. electricity grid mix, or you can say I'm using average California power or Netherlands power, or et cetera, et cetera. And so it's basically just a giant database system. And then you can combine these all into a single score using normalization and weighting that basically takes all these different variables, like climate change will be in kilos of CO2 equivalents, and ozone depletion will be in kilos of CFC-11 equivalents, and water depletion will be in cubic meters of water, et cetera. So what they've done is they've looked at planetary boundaries of what damage is being done and what is doing the most damage, what is basically causing the most disability-adjusted life years, which is something that actually came from the insurance industry. And it's a way of quantifying basically what kills people and what injures them in some other way or makes their health poorer. And then there's also percentage of species that go extinct per year, and people have numbers to track that from, CO2 or lead going into the water supply or acidification, et cetera. And then there's dollars of increased cost of resource use, like for mineral depletion. There's a limited amount of gold in the Earth's crust, and so every ounce of gold that gets dug out raises the price of gold by a little bit because there's just a little bit less gold to go around. And so all of these get normalized and weighed into a single score so that you can compare, the transportation against the energy, against the embodied impacts of the materials, et cetera.
This is a lot of very, fatalistic measurement. How do you personally, compartmentalize? I imagine you must walk around the world and you use a ballpoint pen and you go, oh my God, the, expected life year impact on the human population of this ink is some number of hours. And do you do that?
I mean, yes, it can get grim to think about this stuff in these concrete quantitative terms, but that's just reality. That's what is happening to the world. And this is the problem, is that not enough people are thinking about this. People wouldn't live the lifestyles that they do if they did think about that all the time. Mm-hmm. And so I get through the day with a skip in my step rather than, just sort of screaming at the universe, because the work that I'm trying to do is to improve these things and, give the world better options, better opportunities to ideally not just reduce our existing impacts, but try to find things that can create a positive impact on the world.
So let's talk about the impact that 3D printing has at a very general level. What have you mostly found?
Yeah, the main thing is that it's complicated. There's no one simple answer of 3D printing is green or 3D printing is not green. It depends on the kind of product and the kind of use and the scale of manufacturing and what other manufacturing process you're comparing it to. Like, I've done comparisons of various kinds of 3D printing versus machining, and that's something, it's perfectly fine if you're making a few custom parts, you might machine them. It's pretty rare in mass manufacturing, but can happen sometimes. But so normally 3D printing is better than machining if it's like a thin-walled, complex geometry product, like the cases for most consumer products or something. But if you're just looking at a sheet of material or something that's like a rectangular brick, then machining would be better, because the main impacts of machining are the waste produced and also the energy use, whereas 3D printing, it's mostly the energy. But then compared to injection molding of plastic at scale, where you're cranking out 1 million units a year or something like that, 3D printing is actually way worse. And we're talking an order of magnitude worse for most of the printers that I've measured, and some even by like a factor of 20 or 40, again, depending on the printer and the kind of part. And so this is a problem, because a lot of people assume that 3D printing will just always be greener, but sometimes it's actually a lot worse. And so we need to invent better ways of 3D printing. And like there are two very common myths out there. The first one is that 3D printing is inherently green because it eliminates waste, because it's additive manufacturing.
Right. Anyone who's operated a 3D printer knows something about the waste that you can produce with a 3D printer.
Exactly. And so yes, there are some kinds of printers that can produce parts with almost no waste. Like an FDM printer, printing the right kind of geometry part that doesn't need any support material. Sure, you can generate almost no waste that way. But you know what? Injection molding only generates between like 2 to 10% waste. And so, you've got stiff competition. And then there are printers like an Objet, which generates 43% liquid waste even before you count support material.
Oh, wow. And that's just from the process of the Objet, where it's like clearing the lines out before certain passes and stuff like that?
Exactly. Yeah. And so there's that. And so even if we did eliminate waste from all 3D printing, it actually wouldn't matter that much, because the big environmental impact of 3D printing is actually the energy used during printing. And it's usually like 3/4 of the environmental impacts of a part. And that's including the embodied impacts of the materials that go into the part itself, and the waste that's produced, and the embodied impacts of making the printer itself and transporting it to your location and throwing it in a landfill or recycling it at the end of its life.
Right.
So it's really all about the energy. And right now, 3D printing is usually vastly more energy intensive than injection molding, because it can take hour to print something that would be injection molded in a matter of seconds.
So is that because the energy usage in a 3D printer that's salient here is the kind of baseline energy usage, the background energy usage that it's consuming regardless of the throughput of the machine?
Sort of, although it does actually depend on throughput. Actually, this is, and I have a paper in review right now that's looking at this, and because there are some printers that can print lots of parts at once, like the Objet can do that, or Z-Corp printers or the HP printer can print hundreds of parts at once, and it definitely helps, because with a lot of these printers, they use almost the same energy, whether they're printing one part or 10 parts or 50 parts at a time. And so yes, the throughput does help a lot, but it's not everything. There are some printers that, yes, they print a lot of parts at once, but they use massive amounts of energy. And so it doesn't end up helping in comparison to like a little desktop Affinia or something that only uses 50 watts. And so even though it's pretty slow and only makes one part at a time, it will still use a lot less total energy per part.
So this is where the geometry that you mentioned earlier becomes clear. You can imagine, I guess, a continuum of like a delicate thin-walled part to a simple cube of aluminum. And as you move along it takes more and more energy to produce something like that on a 3D printer and less energy to produce something like that on a subtractive machine.
Exactly. And actually, that's one good thing sustainability-wise about 3D printing is that it aligns the economic incentives with the environmental impacts, where when you're machining, you have an economic incentive to spend the least amount of time machining. And so that makes you prioritize using more material rather than less, because you want to spend as little time cutting away as you can. And then that's wasteful of material. Whereas 3D printing, material use is expensive, basically because both the materials tend to be pretty expensive and because, like you said, the more material you deposit, the more time it takes. And so it gives you an incentive to save materials, and the geometric complexity of parts is free. Whereas with machining, geometrical complexity is what takes time, because that means more cuts. And so it provides a long-term economic incentive to save material just because material use is lined up with the cost of printing. The other big myth about 3D printing being green is that it eliminates transportation, which is, again, anyone who actually does 3D printing will know that's not true, because you still order the raw materials from somewhere. And even if it were true, and it is possible to print stuff with locally made materials, or you can, have a desktop Philibot recycling machine to grind up plastic and print it out right there. But even when that is true, it still doesn't matter, because transportation is usually just a few % of the total life cycle impacts of most products.
Interesting. To take a look at energy usage, did you see much of a difference between different 3D printing processes? The processes maybe that are thermal versus the processes that involve thermoset plastics that cure or anything like that?
Yeah, actually, there's a huge difference. There, again, can be an order of magnitude difference or more between different kinds of printer, and not even necessarily different technologies. Like a Dimension FDM printer, one of the larger scale commercial size jobs, compared to a little desktop FDM printer, just that can be a factor of 10 difference in energy use. And and then the PolyJet had the highest energy use of any 3D printing technology that I've measured. And I've measured, I and the people that I've worked with have measured, 8 or 9 different technologies, basically all the major kinds. So FDM, DLP, PolyJet, SLA, inkjet, inkjet deposition, the Z Corp type machine, and inkjet fusion, the new HP version. And so there's a huge range. It's pretty clear that when people are designing 3D printers, they're not really paying any attention to that at all. They're paying attention to higher priorities for them, which are, print quality and speed and stuff like that. But then to finish up with 3D printing versus other manufacturing techniques and its general sustainability, there are ways in which 3D printing is very green compared to existing systems. So in aerospace and like making airplanes and spaceships and even automobiles sometimes, it is automatically a beneficial technology today because a lot of the parts that you'll find for jet engines and airplanes and things are like machined titanium. And so 3D printing is usually already a greener way to manufacture those parts, and it can enable lighter weight super alloys and things like that. And then even when it's not a greener way of doing the actual part manufacturing, that doesn't even matter because the vast majority of the whole system life cycle environmental impacts of an airplane is the fuel used while it's flying everybody around during its life. And so even if your manufacturing process were like 5 times as energy intensive, it doesn't even matter because 3D printing is really good at making lightweight parts, and that saves fuel during the life of the plane. And just there's one little smaller tangent, which is that 3D printing can be helpful for repairing products where, the product isn't made anymore, and so you can't get replacement parts, but you can go to a website like Thingiverse and just download a CAD model of, let's say, the wheel for a dishwasher rack. And so you don't have to throw away the entire dishwasher. You can just download a CAD model of this little plastic part, print it out at home, and then repair your dishwasher. Now, that's not a huge thing. It's not as big an impact as like saving fuel in aviation, but it is another way where 3D printing can help sustainability-wise.
Right, to sort of reduce rates of disposal and repair and avoiding the purchase of new things entirely.
Exactly. And if you want an in-depth analysis of where 3D printing is beneficial and where it's problematic and what we should do about it, I actually wrote the policy for the OECD for their recommendations for pushing sustainability in 3D printing. And it's a freely available report. It's chapter 5 of their book, The Next Production Revolution. You can just download a PDF of it online. And it lays out what the environmental impacts are of various kinds of 3D printing and how they compare to things like injection molding and machining. And then it gives a whole table of ways in which we can encourage the 3D printing industry to get greener.
Excellent. I'll link to that document in the show notes that accompany this podcast episode. This matter of 3D printing enabling designs which are themselves more efficient in their applications is really interesting, and certainly that's something that that's really propelled adoption by the aerospace industry. Sometimes it's frustrating when you're in the 3D printing field that it feels like the aerospace industry just consistently gives you the best examples and the best references to look at, and you're dying for better examples from other industries as well. But aerospace is a great illustration here because you can actually measure the impact of good design for additive manufacturing and the impact of geometries that you can only fabricate with additive manufacturing in these terms. So is there kind of a rule of thumb, a good heuristic for the entire life cycle impact of, say, 1 kilogram of weight savings on a passenger airliner?
Oh, yeah, there is. I'm not in the aviation industry, so I don't know that number off the top of my head, but there absolutely is. I've seen that number quoted in various places, and I just don't know what the number is off the top of my head, but I do know that that GE's their, I think, GE90 jet engine that they used a bunch of 3D printed parts in was expected to save millions of gallons of fuel every year.
Mm-hmm, mm-hmm. Is there now you mentioned that transportation is sort of a red herring in terms of the environmental impact of 3D printing. Obviously, you're getting your chemicals from somewhere, and that supply chain is probably quite complex. Did you see any impact of part consolidation or distributed manufacturing in terms of sustainability?
Well, again, distributed manufacturing, any environmental impacts there are going to be mostly transportation related, so it's not going to make much difference. But part consolidation can have an effect on the recyclability of products. Basically, the fewer parts there are to take apart, the more cost benefit you get from recycling, because you get more value for less time spent taking something apart. I have not seen hard numbers on that, like how much of a benefit it is. So I can't give you hard data there, but it's something that should help in principle.
So on this program, the topic of design for additive manufacturing comes up fairly regularly. Across the user base of 3D printing, you have a lot of people who are experienced in designing for machining, designing for injection molding, and then they're kind of adding additive manufacturing to their portfolio and discovering that a specialized approach or a thoughtful approach to design for additive manufacturing is required, just like it is for any other production technology, which, of course, is another sort of myth of 3D printing, is that you have complete design freedom and you can just take a design and throw it into the printer. So in terms of, getting the quality of output that you require and the throughput that you require, it's becoming more broadly recognized that design for additive manufacturing is important. Do you have any insights on design for sustainable additive manufacturing at the level of, designing a part and designing the fabrication process on a 3D printer?
Yeah, I have basically a couple, and you can find details on this in that OECD report. There are recommendations for printer operators as well as printer manufacturers. But basically, the nutshell version, the simple version, is to do as much as you can to save material and do as much as you can to make the print faster, which is something that you want to do anyway for economic reasons, because that is the money that you'll be charged is basically based on the throughput of machines, and the throughput of machines is also directly related to the energy use, because most 3D printers, they'll use a fairly constant amount of energy no matter what they're printing, and so it's just a matter of how much time they spend printing. So the faster you can make the print happen, the less energy you'll use printing. And so you can optimize for the print time by doing things like printing many parts at once, filling the whole print bed, if you're working with a printer that has that capability. And you can choose different part orientations. If you have like a long, skinny part, you might print that horizontally so that there are fewer z-axis moves and more just extrusions in a fast line. And for reducing material use, just make the parts as hollow as you can. And a lot of slicers, basically all slicers, will give you at least some basic options for how to hollow out the part that you're printing. But you can also get specialized software that does much more sophisticated internal structures, trabeculation, like a bone, so you can create these highly optimized geometries of little tiny internal struts that will help you minimize material while still keeping whatever mechanical performance you need. You can basically do computational optimization of the amount of material that you use in different places. It's like using finite element analysis software. And in fact, it does use FEA to do its calculations, and it'll, you'll enter in the CAD model and you'll enter in where you're expecting the forces to be coming from, and then it will just wave its magic wand and cut away material everywhere that you don't need it much.
Right, right. I think generative design is an interesting part of this. This effort to match the parts that you're fabricating to their suitability, and create parts that meet the requirements without being over-engineered, without going beyond and having more material and more energy than they need.
Exactly.
So in terms of the energy usage of these machines, which, as you've mentioned, is the largest component in most cases of environmental impact, what is most of that energy going into? Is it actually going into the print process in some way, or is it kind of like a cable box where it's just going into purely wasted background standby energy in like the embedded computers?
Totally. And this varies wildly by printer type. And with most printer types, I haven't actually been able to do those measurements because people are grumpy when you take apart their printer and
these are expensive machines you're experimenting with.
Exactly. Yeah. So the one time that I've really gotten to do a component by component analysis of the energy use was with the Autodesk Ember printer. And it was kind of funny because it was a case where I started out wagging my finger at them because when I did the measurements for the printing, I discovered that it used exactly the same amount of energy to sit there idle as it did to be printing. Wow. And I was like, seriously, guys?
Wow.
And yeah, and they were shocked too. They're like, what? The main thing was that the motors, the X, Y, and Z motor control, they were keeping the precise locations of the motors by always having the motors powered up and engaged. And even when you weren't printing, they just left it like that. But so actually, I was really happy because they came back to me a year later and they said, hey, we think we fixed it. Can you measure it again? And they had reduced the print energy by 20% and reduced the idle energy by 80%, wow. Which I thought was fantastic. And the best part was they didn't even have to change any hardware. They just changed firmware settings so that these motors weren't always engaged. They could use more mechanical brake rather than holding themselves there using power.
Right. And just use limit switches or something when you begin a job to verify the position of the build plate.
Right.
So you mentioned that's the printer you've studied most deeply on this subject. Do you suspect that there's a big difference between that type of desktop printer and a large industrial 3D printer?
Well, there are definitely a lot of these printers that I've measured, both the small scale and large scale, that use almost as much power when they're idling as they do when they're on. Like, I'm trying to remember the SLA printer. Well, I won't mention the brand name, but to get people mad at me. But the commercial scale SLA printer that I measured, it used I think it only used like 40 watts less when it was sitting there idle than when it was printing, if I remember. And this is like a I would have to double check the actual data, but I think that it used like 240 watts of power when it was printing and 200 watts when it was just sitting there. But yeah, you can, if you go through my publications, you can check all the numbers on this stuff. I forget that number off the top of my head, but I suspect that there are a lot of these printers that all it takes is a little bit of attention from the designers to shut down stuff like that.
Right. I wonder if we'll see a little bit more attention paid to that type of thing as 3D printing becomes more of a commonplace production technology rather than a prototyping technology. Because I think in a prototyping setting, people are less sensitive to that type of impact. And in a production setting, sophisticated manufacturers are used to modeling their energy usage and trying to optimize that. And you would hope that they would go back to the printer manufacturers and demand improvements.
Yeah, you would hope. Unfortunately, electricity is so cheap that it's not really a priority for anyone. But I do hope that that stuff happens. And I think you're right that as we start to see larger and larger scale manufacturing operations using 3D printers, there will eventually be some pressure in that direction.
Looking out over the next few years, where do you see 3D printing moving with respect to sustainability? And what do you think the community can do to move it in the right direction?
Well, actually, I would love listeners to start experimenting with printing other kinds of materials because what we've been talking about so far was just the diagnosis of what the big problems are with 3D printing and where it is sometimes greener, sometimes not greener than other manufacturing. Mm-hmm. But actually, what I've been working on for the last couple of years has been trying to create not just diagnosis, but treatments. And I've actually been trying to invent greener materials that cause 3D printing to save energy. And I'm not the only one who's been doing this. There are other people that have been doing it for some years. I'm just the first person who has actually quantified the benefits of it. So like one material that I've invented, with advice from other people, is a combination of mica and sodium silicate, and those things bond chemically at room temperature, and so you're not using energy to melt the plastic. And so with a normal just desktop MakerBot machine that we hacked to replace the hothead with pneumatic extrusion through a syringe of it's just this liquid paste, and we cut print energy by 75%. We cut the embodied impacts of the materials by 80%. We reduced material toxicity because nobody talks about it, but ABS actually is made up of toxic ingredients and outgases while you're printing it. And it improved the resource circularity of the material as well, because when it's printed, it's totally solid and shelf stable. It has roughly the material strength of unreinforced concrete, which is not as high as ABS plastic, just to be clear. Okay. But it's not nothing.
Right.
We had one of those parts that we had sitting on a shelf for a year without any degradation, and then when we dunked it in a jar of water, it dissolved within hours, and we just needed to stir it a little bit by hand. So we haven't tried printing again with that same material, but in theory, you could have your print. When you're tired of your print, you just dissolve it in water, and then you print something else with that same material for a closed loop ecosystem.
So you can actually reconstitute the material and put it back into the printer after dissolving it in water?
Well, like I said, we haven't tested the reprinting yet, but we have tested that you can print with it and it'll be stable, and then you can dissolve it in water. And it was water-based to begin with. So once you evaporate off the water, in theory, it should be printable again. Mm-hmm. And then all of this was also at half the cost of normal ABS printing filament. So it kind of does everything that you want sustainability-wise. The only downsides are, like I said, it's not as strong as ABS plastic, and we're still working on the print quality. Like, the print quality is fine, but it's not the best. It's only like 0.3 millimeter layer height, which is not as good as you can get with FDM, and obviously nowhere near as good as like the HP printer or Objet. So I want more people to experiment with materials like this. There are other companies doing this. Emerging Objects is a good company in the Bay Area. That's a small startup doing this. Binary in Salt Lake City. There's other researchers that are experimenting with 3D printing in chemically bonding pastes that don't require melting. And we need a lot more people working on this, because with with improvements in environmental impact like that, we are approaching parity with injection molding. So we might be able to say that, yes, 3D printing is just always an environmental win compared to existing manufacturing. And that's what I want to create. That's what I'm working on. So that instead of me having to tell you, oh, it's complicated, green 3D print, 3D printing is sometimes greener, sometimes not, it depends, blah, blah, blah. I want us to just be able to say, yes, 3D printing is always greener, because we have invented these materials and processes that make it that way.
So you can really see then the emergence of a portfolio of a lot of different 3D printing processes and materials, where some of them are more sustainable than others, but you can match your requirements to these different materials. There are a lot of 3D printing jobs that you run that are kind of like, quick one-offs, where it doesn't matter if the quality is ideal. You're making a draft of something, or it doesn't matter if it's terribly strong, because you just need a one model out of 50 that you're going to run as part of a product development iteration. And in those cases, you could really cut down on your impact by choosing a material and a process that suits your need.
Absolutely. Yeah. So even today, you could use the materials that I and others have invented as replacements for the 3D printing in prototyping for appearance models and, like you said, rough models. And if we get more people doing research in this and developing new materials, I think we'll easily be able to match the same quality and material strength and other properties that you get from ABS, PLA, nylon, etc.
All right, Jeremy, I'd like to switch gears a little bit and ask you the question that I ask every guest on this podcast about what's your favorite tool?
Yeah. It's not a great answer, but I would probably say that my laptop is my greatest tool, just because I do everything on it. And, it's got a million household uses for both work and play. I use it to write. I use it to do data analysis. I use it to do art. I do a lot of photography. And it can kind of carry most of my life in a fairly small package that, fits in a bag.
Do you feel like what you've been able to do with a laptop has changed a great deal in the last, say, 5 years?
Well, it's funny that you say that, because the laptop, my personal laptop, is actually 6 years old. I bought it just like 4 or 5 years ago, but I bought a refurbished 2012 MacBook Pro because it was the last model where it was in some way upgradable and repairable. Now Apple is super annoying about gluing the battery in and soldering the RAM to the motherboard and all that garbage. And whereas this one, can replace the battery, and I have upgraded the RAM myself, and I had pulled out the optical drive and put in a solid state drive for a while. And so it's actually a way better machine than it was when it was originally sold, and yet has much lower environmental impacts than me having to buy a new machine.
Right. I think of that a lot whenever I see ads for electronics, and particularly some computer manufacturers advertise very heavily the kind of sustainable manufacturing practices that go into their products. And it always strikes me that, it's great, given a choice between sustainable manufacturing practices and non-sustainable manufacturing practices, you would want to see the sustainable ones. But in appearing in an ad that's encouraging you to replace your current piece of electronics with a new one that's manufactured more sustainably, that's kind of a backward way of looking at it. And that buying any kind of laptop, any kind of new thing that replaces a thing you already have, however sustainably it's been manufactured, is a negative impact overall.
Well, usually, unless it is way more energy efficient, for example, which is something that has happened, actually. Today's laptops are much more energy efficient than laptops of maybe not 5 years ago, but certainly of 10 years ago. And things like modern refrigerators are way more energy efficient than ones from 15 years ago. And so there are sometimes where it makes sense to do that replacement.
From that perspective, do you have a recommendation for the listeners? What's the first kind of old thing that we have lying around our houses that we should probably run out and upgrade right away?
Oh, if you have a plasma TV, get rid of that and replace it with an LCD. Because LCD monitors use less power when they're on than most plasma TVs do when they're sitting there idle.
No kidding.
Oh, yeah. And then probably refrigerator, because it's something that is on 24 hours a day. And it's something that people don't generally upgrade very often, but has made big efficiency improvements in the last 10 or 15 years.
Excellent. I'll take a look at mine right away. So, Jeremy, as I mentioned, I will link to your OECD paper in the show notes that accompany this episode, so listeners can find that link in your podcasting app. But if listeners want to take a look at the breadth of what you've done and see some of the materials you've invented, where should they look? So
far, I only have one paper out on the invention of new materials, and it's a little bit of an awkward one because we had the worst thing happen that as a scientist you ever want to happen, which is that I'll try to keep this short, but basically we were printing in pecan shell flour because we were trying to upcycle agricultural waste. And we've gotten these great results, cutting print energy 75%, material impact 80%, et cetera. And we eventually used up the material that we had, and we ordered more from a different source, and it acted radically differently. And we're like, hey, what's up with that? And we were simultaneously wondering why the pecan shell material was working so much better than all the other cellulose-based materials that we had tried, like sawdust and ground up cacao shells and other things. And we eventually found that actually the supplier had lied to us about it being pecan shell flour. It was actually the mineral mica. And we only found this out after we published the paper in the academic journal, and we're like, oh, Jesus, okay. Thankfully, we didn't have to retract the journal article, like the cold fusion people in the 90s did.
Right.
We just had to file a correction. Basically, we redid all of our analyses once we found out what the material really was. And thankfully, it didn't change any of the impacts very much, just a few percent on everything. So environmentally it was still great. It just wasn't as good a story in terms of the upcycling agricultural waste to create a compostable biomaterial, which was the goal.
Right.
And we actually have accomplished that with real pecan shell flour since then, but it's not in that publication. But so that's a good publication to where it also mentions some of the other many materials that we tried. We tried like rice flour, ground up orange peels, a few different kinds of sawdust, pine, oak, bamboo, and a whole slew of other things. And that paper talks about the energy savings and a little bit about toxicity and the cost. And so it gives a pretty good, well-rounded picture of what it means to develop greener 3D printing materials.
Excellent. Jeremy Faludi is an assistant professor of sustainable design at TU Delft. Jeremy, thank you so much for coming on the program today.
It's been my pleasure. Thanks for having me.
If you're interested in learning more about Jeremy's work on the sustainability of 3D printing, check out the link in the show notes in your podcasting app or visit thedigitalfactory.com. If you do that, you'll also see all of the videos from all of the Digital Factory conferences, and you can watch them for free. The Digital Factory podcast is brought to you by Formlabs. Join us at the Formlabs User Summit on October 1st in Berlin. Meet other super users and learn best practices and techniques for getting the most out of 3D printing. Visit summit.formlabs.com for more information. With the Digital Factory podcast, I'm John Brunner.